This video is sponsored by RenderHub, and they just have added a full and comprehensive guide to all 3D formats, but more on that later in the video. If you want to use photogrammetry in your projects, then you've got a few options out there that can change your workflow and make it much better. The software I'm going to talk about today each have strengths and weaknesses, so I will give you the background of each software, also its tools and features, so you can decide and make an informed decision. Before we continue, let me show you something interesting, which I recently discovered on RenderHub, a comprehensive guide to virtually every 3D format you are likely to encounter throughout your 3D career as a 3D artist. Everything is organized into a single sheet that provides a high-level compression of key features, including support for UV mapping, PBR materials, skeletal rigging, and animation data, so you can easily understand the strengths and limitations of each format. And I personally booked it right away. You can even expand every entry for more details and browse marketplace assets available in that format. Speaking of the marketplace, you guys really need to check it out. Whether you are looking for game-ready assets, characters, materials, or pretty much anything else for your projects, chances are you will find it there. And don't forget about the gallery and blog post, where you can interact with the community and share your own creations. So, if you are interested in RenderHub, you will find all the necessary links in the description. First of all, the story of RealityCapture starts with a Slavic company called Capture in Reality, founded by researchers and computer vision experts who wanted to solve one of the biggest problems in photogrammetry, which is speed. You see, back in the early 2010s, generated 3D models on photographs could take many hours or even days, so the team developed new algorithms that made reconstruction dramatically faster while still maintaining high accuracy, and in 2016, they officially released RealityCapture. The software quickly gained attention among game developers, VFX studios, surveyors, and cultural heritage organizations because it could process huge photo datasets much faster than competing software. Its reputation grew even further when Epic Games acquired Capture in Reality in 2021, bringing the technology into the Unreal Engine ecosystem, which, as you can imagine, helped make it more accessible to different creators. So if you're new, this is a great place to start. What really makes RealityCapture stand out was its incredible processing speed, because it is known as one of the fastest photogrammetry software out there, thanks to the heavy GPU acceleration, the ability to handle thousands of images efficiently, and its unique workflow for combining photographs with laser scans in a single reconstruction. Just to make sure that you're choosing the right software, artists love it for creating game assets, environments, and VFX scans, while a lot of surveyors use it for mapping and digital twin projects. Also in recent years, Epic has continuously improving the software, with faster reconstruction and texturing, improved day-to-day workflows, better GPU utilization, and support for larger datasets. And one of the biggest recent changes was Epic's move to rebrand RealityCapture under the RealityScan umbrella, adding features like AI-assisted masking, LiDAR integration, and tighter connections between desktop, mobile, and Unreal Engine workflows. On the other hand, Agisoft Metashape actually is one of the longest standing software in modern photogrammetry. You see, it was first released in 2010 under the name Agisoft Photoscan, developed by Agisoft with the goal of making professional photogrammetry accessible on different desktops instead of requiring expensive specialized hardware, because photogrammetry and 3D scanning, as you may know, was only accessible to the VFX industry, for example, and over the years, it earned a reputation for producing extremely accurate photoscans, especially in fields like archaeology, cultural heritage preservation, VFX, surveying, and drone mapping. In 2019, Agisoft rebranded the software as Metashape, and I think they did this to better reflect the fact that it had grown beyond simple photo processing into a complete 3D reconstruction platform, capable of generating dense point clouds, textured meshes, digital elevation models, orthomosaics, and GIS-ready spatial data, which is cool to say the least. Also, by the way, many consider this software to be more advanced than RealityCapture. One of Metashape's biggest strengths is the amount of control it gives you over every stage of the reconstruction process, because it supports high-quality image alignment, dense point cloud generation, advanced texture baking, camera calibration, laser scan integration, scripting through Python, and it supports both Windows, macOS, and Linux. Unlike many competitors, which focus mainly on speed, Metashape often is praised for its reconstruction quality and flexibility. And Agisoft has continued to expand the software with recent updates, as I said, because they added AI-powered automatic masking, improved LiDAR processing, better orthomosaic editing tools, APRO tag detection, enhanced cloud calibration through Agisoft Cloud, image-based shape drawing, and new workflow improvements for handling large datasets and professional surveying projects. Even with the rise of Gaussian splatting, Metashape remains one of the industry's go-to tools, especially for creating high-quality 3D scans from photographs. Now let me tell you about Meshroom, which wasn't created by a single company trying to sell photogrammetry software. Instead, it grew out of the open-source Atlas Vision project, which is a collaboration between researchers, universities, and visual effects studios that wanted to make a better computer vision and 3D reconstruction technology, and they wanted it to be free. You see, the project combined years of research in structure from motion, or SFM, multi-view stereo, and camera tracking into an easy-to-use software with a visual node-based interface. The thing is, the software is relatively new. Since its public debut in 2018, Meshroom has become one of the most popular free photogrammetry tools, especially among hobbyists, indie game developers, and VFX artists looking for professional workflow without the cost of commercial software. So if you like what you hear, I think this is a great starting point. And what makes Meshroom stand out is its flexible node-based workflow, which lets you inspect and customize every stage of the reconstruction process, instead of relying on a one-click black box. It also supports automatic camera calibration, dense point cloud generation, high-quality mesh reconstruction, texture baking, and it can process projects locally, or even across render farms. Recent releases have expanded Meshroom beyond traditional photogrammetry, because they added a plugin architecture, new pipelines for LiDAR processing, SDR panoramas, object reconstruction, color calibration, raw image processing, also improved GPU performance. On the other hand, Pix4D Mapper traces its root back to Pix4D, which is a Swiss company founded in 2011 as a spin-off from EPFL, one of Europe's leading research universities. Before I dive deeper, the software is considered the best in drone photogrammetry and GIS, and you will know why in a bit. The company's founder wanted to bring advanced computer vision and photogrammetry research out of the lab into some practical applications when it comes to drones, surveying, construction, agriculture, and mapping. The software quickly became one of the first professional desktop software capable of transforming aerial and ground photographs into highly accurate 2D maps, in addition to 3D models, point clouds, and terrain data. And over the years, it has been used to document everything from archaeological sites and construction projects to volcanoes, mountains, and large infrastructure developments around the world. Now, what makes Pix4D Mapper stand out is its focus on precision in addition to geospatial accuracy, rather than focusing on creating game assets or VFX models, as I said. So in other words, it has real-world applications. It supports RGB, thermal, multispectral, fisheye, and drone imagery, and it offers powerful tools like ground control point support, unique ray cloud environment for very fine reconstruction accuracy, also automatic point cloud classification, and detailed measurement tools for distances, areas, and volumes. Also in recent years, the software has shifted much of its innovation toward Pix4D Matic, which is a newer engine made to process massive drone datasets over 40% faster, while Pix4D Mapper continues to receive maintenance updates, in addition to new camera capabilities and some workflow improvements here and there. COLMAP also began as an academic research project, rather than a commercial software. It was developed by Johannes Schomburger during his PhD research at ETH Zurich and the University of North Carolina, with one goal, which is create a highly accurate end-to-end pipeline for structure from motion and multi-view stereo reconstruction. And it was released as a free, open-source software under the BSD license. You see, COLMAP quickly became one of the most influential tools in computer vision research. While it might not have the polished interface for the commercial software like RealityCapture or Metashape. It has essentially become the backbone of countless research projects and modern 3D reconstruction pipelines, including many NeRF and Gaussian splatting workflows. Now, what makes COLMAP stand out is its reconstruction quality and flexibility, because it supports both graphical and command line workflows, also automatic and manual reconstruction, GPU-accelerated feature extraction and matching, multiple camera models, dense point cloud generation, and highly configurable reconstruction settings. It also scales from small object scans to massive image collections, and integrates well with Python through PyColmap. 3DF Zephyr is also one of the most popular photogrammetry software. It was released back in 2014, and the interesting thing is that 3DFlow Zephyr was built entirely on 3DFlow's own in-house photogrammetry technology, instead of relying on third-party computer vision libraries, which is something that set it apart from many competitors. In fact, Zephyr became one of the first photogrammetry software to launch on Steam, which helped introduce 3D scanning to a much wider audience through its free and light editions, while still offering advanced tools for surveying, VFX, engineering, and game development. And one of the software's biggest strengths is that it offers a complete end-to-end photogrammetry pipeline in a single place. For example, of course, it can reconstruct 3D models from photos or even extract frames directly from videos. It also supports both incremental and global reconstruction pipelines. In addition, it can generate point clouds, texture meshes, normal and displacement maps, and it includes built-in mesh editing, measurement tools, laser scan registration, georeferencing, Python scripting, and direct uploads to platforms such as Sketchfab, which is kind of a bonus. You see guys, these software are really complicated and they have lots of features and tools, so this was kind of a quick overview of what they have inside. So if you are interested, you will find all the necessary links in the description. And there you have it guys. If you like this video, please give it a thumbs up. Also please subscribe to the channel to receive more videos like this. Thank you very much for watching, and I will see you in the next one.